Also this week we're going to look at the integration of sine squared x and cos squared x. And I've actually just straight away put up the two results that you need to integrate these. You can see that they look very similar. Both of them involve a half out the front and an x and a half sine 2x. The only difference, of course, is the sign in front of that. Sine squared x is a half x minus a half sine 2x, and the integral of cos squared is a half outside of x plus a half sine 2x. And I'm actually not going to derive these two results because I'm going to leave this for you to do. So I'd like you to derive these, and when you have derived those, I'd like you to either take a picture of them, save it as a picture file, or you can even type it into Word using the equation editor. But I'd like you to derive them and take a picture of your proof, whatever it might be, and upload to a discussion that I'm going to put on Schoology for you. So that's the method that I'd like you to use to submit this, to post it to the discussion on Schoology that I'll put up. But I'd like you to have a go at deriving these two. I will give you a hint of where to start. The last year, at the end of last year, we looked at a result for the double angles of sine and cos. And the one that we're particularly interested in is going to be cos 2x, and that was equal to cos squared x minus sine squared x. And with this result, we're actually able to relate trigonometric functions that have squares in them and a trigonometric function that doesn't have a squared in it. Now, if you were to look at these, the two sides of this equation, you can't integrate the right-hand side, or not by methods that we have at the moment. We can't integrate that right-hand side, but we could integrate the left-hand side. We know how to deal with this kind of a function. So what this is going to allow us to do in principle is replace a cos squared or a sine squared with something in terms of cos 2x. This result at the moment has cos squared and sine squared in it. We're only interested in one at a time. So what you'll actually also need to use is the Pythagorean identity. To replace one of these results, so you could use it to get rid of the cos squared, okay, and replace the cos squared with 1 minus sine squared, or you could use it to replace the sine squared with 1 minus cos squared, and that'll give you an expression involving cos squared and cos 2x, or sine squared and cos 2x, and from there you're going to be able to make a pretty easy substitution into the integrals to derive this result. So those two are going to be your crucial two results that you're going to need to be able to prove these integral results. I'd like you to derive those and upload them to discussion on Schoology. Even if you can't manage to get them out, do the best that you can, get as far as you can. I'm happy for you to discuss this as long as you can do them on your own in the end. Also, even if you can't manage to derive them, you can still use these to complete the exercises that I'm going to set. I'll just be photocopying an exercise from a textbook and uploading that as a PDF for you to access. But that's the work on integration of sine squared and cos squared that I'd like you to do this week.